This is episode 17 of the Big Data MBA video educational series. And in this episode, I want to cover and explore and talk about the power of an incremental use case by use case based approach for building out your data and analytics strategies and your capabilities. This has a couple of immediate advantages. One is it's an ROI driven approach that requires and drives alignment, close alignment and collaboration with the business. But also, maybe even more importantly, it activates the economies of learning. So let's talk about this approach through a simple example. Let's say I'm a high-tech manufacturer, and I'm very dependent upon suppliers and contract manufacturers to build the subassemblies and components that comprise my overall product. So this is actually a use case that's relevant for many organizations that are dependent upon suppliers to provide parts that ultimately find their way into the end product. And so we go through our value engineering approach, we go through our envisioning approach, we go through a prioritization process, and we decide as an organization, as a group, that the most important use case we can start with is how do we improve vendor quality? Think about all the vendors and again, the contract manufacturers and what can I do to improve vendor quality? And let's say we've gone through some of financial analysis with our and such, and we determine that this is worth $60 million a year to us. To be able to improve vendor quality by some percent is worth $60 million a year. Now, our data science team will go through a process to identify sort of the minimum viable number of data sets that they need so they can move quickly to attack this problem. We don't want to look at hundreds of data sets, but what are the three that give us the most immediate return on investment? And so, again, we go through a process and they identify, in this case, three, but maybe they identify four or two, a minimum number of data sets that are most valuable for starting to achieve this vendor quality improvement, driving this use case immediately without having to wait 18 months, 24 months before we start seeing any value scored out at the end. And as part of that process, let's say we have to build two analytic assets, two analytic modules. Analytic module A, I'm going to call anomaly detection. This is going to continuously monitor the vendor quality and flag anomalies. And B is the creation of a vendor quality score that I'm going to use to not only monitor, but I will use that score in my supplier and contract manufacturer negotiations. So 3 data sets, 2 sets of analytics needed to actually help me start moving down the path to realizing that $60 million of vendor quality improvement. By the way, from a financial, what's the value of my data perspective, what's the value of my analytics, I can use a very simple approach to say, hey, if 3 data sets help me deliver $60 million of value, then each of those data sets are worth roughly $20 million. And if I have 2 sets of analytics that are help me deliver that 60 million, I can allocate 30 million to each of them. So now I've got a ballpark range understanding of which of my data sources are most valuable. Great start. Second use case comes along. And this is about improving vendor reliability. Vendor quality is good, but if I can't have the products delivered in time, full loads without sort of the recommissioning and decommissioning process of vendors and contract manufacturers canceling what they can deliver to me, right? Vendor reliability becomes very important. Now, in our analysis here, it's worth $20 million, right? It's not quite as important, but it's still important, which is probably why it was second. And to do this, we've discovered the data science says, hey, we need two data sources in order to really start attacking this problem. Data source A and data source D. Now, the beauty of this model is that data set A is already in my shareable data repository. I don't know what you call the repository. Is it a data warehouse, data lake, data lakehouse, data mesh, data fabric, data BS? I don't know what it is, but I've got this ability to share my data sets across my use cases, and I'm going to reuse data set A to help me solve this use case 2. And I'm going to have to add another data set D. Now, the advantage of use case A is I get to use use case A at 0 marginal cost. It's already there. I've already paid for it. I've already put it into my shareable environment. I've already handled metadata management and data governance and data quality and data enrichment, all these things that makes data a true asset, right? So I get to reuse data set A at 0 marginal cost, but it delivers value. So I can, again, allocate the $20 million to the 2 different data sets. And in the analytic assets aspect, right, I'm going to reuse my anomaly detection because I'm going to continue to flag vendor reliability, but I need to create a new analytic asset, a module called module C that's going to create a vendor reliability score that I'm also going to use in my vendor and my contract manufacturer negotiations. And I'm going to allocate the $20 million evenly akin to these 2 different analytic modules. Analytic module A, which, by the way, has already been built. I get to use that for free. I'm going to reuse what's there, but it gets an allocation of $10 million of value because that same analytic module can be used to address vendor reliability. I think you can see the process here. Use case by use case. I understand the value of the use case. I go through a process to figure out what data sets do I need, not every data set, but what are the minimum viable number of data sets to allow me to start tackling this problem, and reuse the ones that I have, right, to slowly build out my data repository, use case by use case process, reusing the ones I already have in it and adding new ones as dictated by use cases. And the same thing with my analytic assets, right? Reusing those as much as possible and building new ones in relationship and support of the use cases. Very simple process, use case by use case. Each one has a positive ROI. Each one reuses what we learned in the first use case to apply it to the second and third use case. There's one other benefit here. Let's say one of your big giant, big-brained data scientists figures out how to improve that anomaly detection module. They're going to use some kind of new algorithms and data transformations and feature engineering techniques and whatever, and they're going to figure out a way to improve anomaly detection by 1%. They can affect the predictive accuracy and predictability and recall and precision by 1% by doing some of their data science magic. The beauty is that every use case that used that anomaly detection module just got 1% more effective. And they got it for free because of the ability to learn and continuously learn and adapt. And this leads us then to the Schmarzo economic digital asset valuation theorem. Yes, my effort to get a Nobel Prize in engineering, because there was 3 impacts in that use case by use case approach, 3 impacts that drive the fundamentals of the economies of learning. Number 1, as I start going on a use case by use case basis, I start to flatten my marginal costs. Why? Because the data sets that I need are already in a shareable environment, and many of the analytics I'm going to need and reuse are already built. I'm just reusing them over and over again, and in many cases using those at near zero marginal cost. Number 2, my ability to reuse my data and analytic assets allows me to shrink time to value and de-risk new use case implementations, allowing me to increase my marginal revenue. So marginal costs flatten, marginal revenue increases. That looks pretty sweet. There alone, you have a reason to go talk to the executives and start talking about data and analytics as economic assets. It makes total sense. But wait, there's more. The ability to continuously refine and adapt my data analytic assets and make them more effective means that any improvements I make to those data and analytic assets ripples through all the previous use cases that reuse that same asset, creating this asymptotic increase in value that explodes as more and more of these use cases reuse these continuous, and we're really exploiting the economics of compounding, how 1% improvement compounded over 10, 20, 100 use cases has this incredible growth factor. Anyway, I hope you found this explanation useful. Again, it's really about understanding the power of a use case by use case approach, not only from a perspective of how we build out our data and analytic assets, and not only from the fact that we can drive positive ROI through business collaboration, but maybe and more importantly, it shows how we can exploit the unique economic characteristics of data and analytics and these economies of learning, because you're all on the map here trying to get me that Nobel Prize. Thanks for listening. Talk to you all later. Cheers.